Okay, so a pleasant day to everyone. Okay, so for today in Introduction to Geometry, we move on to our second module, which is about relationship among lines and angles, or relations among lines and angles. And for today, the first topic for that is about angle pairs. Okay, so angle pairs in geometry are just those, of course, two angles. Okay, they're a pair of angles and they have like a special name. Okay, so these angle pairs have unique properties, the first one being the complementary angle. So the complementary angle are two angles. Okay, so it's a pair of angles whose sum measures 90 degrees. Okay, so we've learned that throughout your elementary years. Okay, and this is just a bit of a review. Okay, and this angle pairs has a second type. Okay, so there's the supplementary angle. So the supplementary angle is an angle whose sum measures 180 degrees. Okay, so for complementary angles, we call each of the angles as complements. Okay, so angle A has a complement of angle B if and only if the sum of their measurement is 90 degrees. Okay, and for supplementary angles, we have supplements. Okay, so angle A can be the supplement of angle B if and only if the sum of their measurements of those two angles is 180 degrees. Then we have vertical angles. Okay, so vertical angles, imagine angles like this. Okay, so there's an X, so we have here two angles. Okay, so this one are opposites of each other, and those two opposite angles actually have the same measurement. They are congruent. Okay, so vertical angles are any pair of angles that are opposite to each other and have equal measurement or are congruent. Then we have adjacent angles. Okay, so these angles are the simplest type of angle pairs. So they are two angles that share a common side. Okay, so that's going to be our first topic for today. The first one is about adjacent angles. Okay, so as you can see here, we have an adjacent angles, or we have adjacent angles here. So we have angle ADJ and angle JDC. Okay, so those two angles are under a bigger angle. It's called angle ADC. Okay, so how did angle ADJ and angle JDC become congruent angles? So the first condition is that they need to have a common side. Okay, so their common side is side DJ or ray DJ or ray JD. Okay, whichever of those two. Those are valid names. Okay, and also they have a common vertex. That's the second condition. Okay, so the common vertex is of course point D. So they have a common ray or a common side, that's ray DJ or ray JD, and they have a common vertex, and also they have no common interior points. Those are the three conditions that must be satisfied in order to name a pair of angles as adjacent angles. Okay, so let's continue with the definition of an adjacent angle. Okay, so again, to define an adjacent angle has two angles that share a common side, common point, and no common interior point. We already analyzed the first figure on the left side, so that's angle ADC. Okay, they share a common ray, which is ray DJ or ray JD, and they have no common interior points, and they share a common point or common vertex, and that's point D. So that's why angle ADJ and angle JDC are adjacent angles. Then we have here on the figure on the right, we have here angle AED. Okay, and it's composed of three angles in its interior: angle 1, angle 2, and angle 3. Okay, so when you draw a line BC on angle AED, we form an adjacent angle for angle 1. Okay, so the adjacent angle to angle 1 is angle ADC. Okay, as you can see, they have a common vertex, so that's point B, and also they have a common side, which is segment BC, and also they have no common interior points. Okay, so for angle BCD there and angle 3, their common side is angle BC, and their common point or their common vertex point is point C. Okay, so for angle 3 and angle ECF, they have a common point, which is point C, and also they have a common side, which is segment EC. Okay, and they also have no common interior points, so that's why they are adjacent angles. Okay, so moving forward with complementary angles. Okay, so we have here two illustrations of complementary angles. So the first one on the left side, we have angle HOE or angle EOH. Okay, so we have there inside of angle HOE, we have two angles, angle HOP and angle POE. So those two angles are complementary angles, and angle HOP is the complement of angle POE and vice versa. And also on the left figure, we also have two angles that are complementary. So angles 1 and angles 1 and 2 are complementary angles, and angle 1 is the complement of angle 2 and vice versa. So how do we say that they are complementary angles? So if you notice on the angle, there's kind of like a box shape symbol there, so that indicates that the angle HOE or angle EOH measures 90 degrees, and also the sum of the measurement of angle 1 and 2 measures 90 degrees. Okay? Okay guys, so for this one, for the complementary angle here now given on the left side, so we've already established that angles 1 and 2 are complementary angles because of the square sign, that square symbol that we see there on at the middle of the vertex. Okay, at the vertex of the two opposite rays. Okay, so we want to find the measurement, okay, for angles 1 and 2 for this problem. So how do we find the measurement of angles 1 and 2? Okay, so we're given here the illustration. So we could simply use the definition of a complementary angle. Since we've already established that angles 1 and 2 are complementary angles, we can say that the measurement of angle 1 plus the measurement of angle 2 is equal to 90 degrees. Okay, so we got that one correctly. So for the substitution part, what we have to do is we simply substitute the measurement of angle 1, which is 7 over 6x, okay, 7 over 6x plus 5 degrees, okay. So always try to put a parentheses so that you won't get confused when adding or subtracting or performing any arithmetic operation. And also we have here 3x minus 9 degrees, okay. So we have here 3x minus 9 degrees. Okay, so we're going to equate that to 90 degrees. Okay, so now we have an equation. 7 over 6x plus 5 plus 3x minus 9 is equals to 90 degrees. The next step is we have to put our constants on the right side and our variables here on the left side. Okay, so that's 7 over 6x. Okay, 7 over 6x plus 3x is equal to, okay, so we have a constant here, 90 degrees. So that's plus 5 on the other side. We have to transfer that. It's going to be minus 5, and then minus 9, that's going to be plus 9. Okay, so that's 7 over 6 plus 3x, that's 25 over 6. So 25 over 6, okay, so that's x. 25 over 6x is equals to, what's 90 minus 5? That's 85 plus 9, that's 94. Okay, so 94 degrees. So in order to find the value of x, so you simply have to multiply this by the reciprocal of the x value there. So we have 25 over 6. So what's the reciprocal of 25 over 6? That's simply 6 over 25. Okay, so also you also do that on the right side. Okay, so distribute. Okay, so x is now equal to, so we've already canceled that, so 94 times 6 over 25, that's simply 564 over 25. Okay, 564 over all over 25. So your answer is a fraction. Okay, so that's how we got the value of x. Okay, so for the next step, we simply substitute the value of x, so we've already solved it, 564 over 25, to the values of angle 1 and angle 2. So angle 1 is equal to 7 over 6 x plus 5, okay, plus 5 degrees. Okay, so you simply substitute the value of 564. Okay, so again, that's measurement. Okay, so 564 over 25. So 564 over 25. Then close parentheses plus 5. Okay, and then you also do that with angle 2. Okay, again, so what's the measurement of angle 2? Angle 2 measures simply, okay, angle 2, let's write that cleanly. Angle 2 is 3x minus 9 degrees. Okay, quantity 3x minus 9 degrees. Okay, so again, we substitute the value of x. So 3 times 564. So let's write that cleanly. Okay, so 564 all over 25, okay, and close parentheses minus 9. Okay, so we simply compute. Okay, so what's 7 over 6? Okay, so 7 over 6. 7 over 6 times 564 over 25. So that's simply 658 over 25, and then plus 5. So the answer is 783 over 25. Okay, 783 over 25. Then, since we're looking for the value of the angle in 2 decimal places, okay, so the value is roughly 31.32 degrees. Okay, so this is the measurement of angle 1. Okay, so it's how about for the measurement of angle 2? We have here, okay, we have here 3 times the measurement of angle x. Okay, so I mean of x. So that's 564 over 25. So that's simply 1692 over 25. Then minus 9. So the answer is 1467 over 25. Okay, and we have to convert that into decimals. Okay, so if it's a decimal with 2 decimal places on it, okay, so the answer is 58.68. Okay, so now we have the measurement of the 2 angles. For the measurement of angle 1, we have, okay, 31.32 degrees. And for the measurement of angle 2, we have, okay, I'm sorry, for measurement of angle 1, we have 31.32 degrees. For the measurement of angle 2, we have 58.68 degrees. Okay, so if you add both of those measurements just to check whether your answer is correct, so measurement of angle 1 is 31.32 plus the measurement of angle 2, which is the 58.68. If you add those two, you get 90 degrees. Okay, so that proves our statement that the measurement of angles 1 and 2 are correct. And we also have the value of x here, which is 564 over 25. Okay, so well done for computing for the values of algebraic expressions using complementary angles. Okay, so we've already discussed two very unique angle pairs. The first one are adjacent angles. Okay, so adjacent angles are again angles that are having the same side and they have a common vertex or a common endpoint, and they have no common interior points. And then we also have complementary angles, 2 angles that measure 90 degrees. And we also solved the problem involving algebraic expressions using our knowledge about complementary angles. Now we move on to supplementary angles. So here on the left side we have a figure, angle SUL. So angle SUL is a straight angle, and it has two angles, angle SUP and angle PUL. Okay, so on our figure we have here a supplementary angle. Okay, so moving forward with supplementary angles, we have here on the left side, we have a figure on the left side, so that's angle SUL. And angle SUL is a straight angle, okay? So angle SUL has two angles. It's composed of two angles. We have angle SUP and angle PUL. Angle SUP is the supplement of angle PUL and vice versa. Okay, so we have angle SUP is the supplement of angle PUL. So that simply means that the measurement of angle SUP combined with the measurement of angle PUL measures 180 degrees. Okay, supplementary angles, two angles whose measurement is 180 degrees. Okay, and because of the nature of supplementary angles, we move forward to the postulate that describes the relationship between angles and lines. Okay, and the first most common relationship that we know of in geometry for supplementary angles and lines involving two lines is called the linear pair postulate. So the linear pair postulate states that if two angles form a linear pair, then they are supplementary angles. So as you can see here, we have four angles on the right figure. We have angle 1, angle 2, angle 3, and angle 4. Angles 1, 2, 3, 4 are formed by two lines, okay? Two intersecting lines. Okay, so we have here actually four linear pairs when those two lines intersected. So the first linear pair is angles 1 and 2. They measure 180 degrees, and therefore angles 1 and 2 are supplementary angles. And also we have angles 2 and 3. So they measure also 180 degrees, and therefore angles 2 and 3 are also supplementary angles. And we also have angles 3 and 4. Okay, so if you look at them, 3 and 4 going up, so that means their measurement is also 180 degrees, and also they are linear pairs. And angles 1 and 4 are also linear pairs, and also their measurement is also 180 degrees. Okay, so we have here a problem involving supplementary angles, okay, and a problem involving algebraic expressions, okay, and using our knowledge about supplementary angles. So we have here the measurement of angle GOW. Okay, so the measurement of angle GOW is 180 degrees, so it's a straight angle. And we also have the measurement of angles GOR and angles GOR and ROW. So angles GOR is 4/3 x minus 12 degrees, and angle ROW is 9x plus 11 over 7 degrees. So how do we solve this? Okay, so our knowledge, what we know is that the measurement of angle GOR, okay, is 4/3 x minus 12, okay, and if you add that measurement to the measurement of angle ROW, okay, so ROW measures 9x plus 11 over 7 degrees, okay. So since those two are supplementary angles and they are supplements of each other, then we can say that their measurements is equal to 180 degrees. Okay, so now we can compute for the value of x here to solve for the missing values for the measurement of angle GOR and the measurement of angle ROW. Okay, so we have here 4/3 x, okay, minus 12. Okay, so we always have to use parentheses so we won't get confused on what to add or subtract or to arithmetically compute. Then we have 9x plus 11. Okay, so 9x plus 11 over 7 degrees. Okay, so we have that equation laid out, is equals to 180 degrees. So our next step is, of course, we have to isolate our variables here. on the left side, so that's going to be 4/4 x plus 9x. Okay, so all of our variables are on the left side, and on the right side we have our constants. So that's equals to 100, okay, 180 degrees. So that's minus 12, so this is going to be plus 12 here, plus 12, okay, and that's plus 11 over 7. That's going to be minus 11 over 7 here on the right side. Okay, so now that we've isolated our variables, okay, so we have here 4/3 x plus 9x on the left side, so those are our variables, and we've isolated from the constants. So the constants are 180 plus 12 minus 11 over 7, so that's why it looks neat. Okay, so we can solve now for the value of 4/3 plus 9x, and the value for 4/3, okay, so that's 4/3 plus 9, so that's simply 31 over 3x. Okay, 31 over 3x is equal to 180 plus 12 minus 11 over 7. Okay, so that's simply 1,333. Okay, so if you use a calculator, that's going to be the answer, or if you want to do it manually, that's also okay. So that's 180 plus 12 minus 11 over 7. The answer is 133 over 7. Okay, so to get the value of x, what we have to do is we have to multiply this entire equation. This 31 over 3x is equal to 1,333 over 7 by the reciprocal of 31 over 3. Okay, so what's the reciprocal of 31 over 3? That's simply 3 over 31. Okay, so we multiply that, okay, and this cancels out. Okay, and when you multiply that there, and we multiply 3 over 31 by 1,333, 1,333 over 7, okay, when you multiply that, you get 129 over 7. Okay, so this is the value of x. Okay, so you don't have to put degrees. Okay, so for the next step, we're going to have to substitute the value of x to the angles, to the algebraic expressions and their angles, for angle GOR and angle ROW. Okay, so we have here the measurement of angle GOR. So the measurement of angle GOR is 4/3 x minus 12. Okay, so we simply substitute the value of x there, so that's 129 over 7 minus, okay, 129 over 7, close parentheses, and then we have to subtract this expression by 12, okay, as written for, as given for angle GOR. And then we have angle ROW, okay, ROW, okay, so we substitute the value of x there, so that's 9 times 129, okay, 129 over 7, and then we have to add 11 over 7 to this expression, as what's given for angle ROW. Okay, then we have we're going to get the degree measurements of angle GOR first. Okay, so we can get it now by multiplying. Okay, so that's 4/3 times 129 over 7, so that's the value of x, and then you have to subtract the answer from 12, and you get 88 over 7. Okay, so the measurement of angle GOR, okay, is equal to 88 over 7. Okay, so let's write that cleanly. Measurement of angle GOR is equal to 88 over 7, or if you translate that into decimals, okay, so that's 12.57 degrees. Okay, so let's get the value for angle ROW. Okay, so that's simply, okay, so let's just write that down. Measurement of angle ROW, okay, is equal to, okay, so if you use a calculator, that's like 9 multiplied by 129 over 7, that's the value of x, plus 11 over 7, okay, from the given. So that's in degrees. So our answer is going to be 1172 over 7, okay? And if you translate that or transform that into a decimal, you're going to get 167.43 degrees, okay? So the measurement of angle GOR is equal to 12.57 degrees, okay? And the measurement of angle ROW is equal to 167.40. Okay, let's write that cleanly. Okay, so that's the measurement of angle 167.43. Okay, so and the measurement for angle, and we have here the measurement for angle ROW. Okay, so the measurement of our angle ROW is 167.43 degrees, and angle GOR, measurement of angle GOR, is 12.57 degrees. Okay, so what we do now is we want to check if that's correct. So we simply add, okay, 12.57 degrees plus 167.43 degrees, and lo and behold, you get the measurement of angle GOW, which is what we want. Okay, because they are supplementary angles. So the measurement is 180 degrees. Okay, so that's it for supplementary angles involving algebraic expressions. Okay, so let's circle our answers here. 12.57 degrees and 167.43 degrees. Okay, so now we're on our last type of angle pair. Okay, so we've already tackled about adjacent angles, complementary angles, and supplementary angles. Now we go to vertical angles. Okay, so vertical angles are those types of angles that are opposite to each other. Okay, so they are opposite angles and they are always equal in measurement. Okay, so how do you prove that? Okay, so for example, we have here in the figure on the left side, we have here two lines, line P and then line Q. Okay, and line P and line Q, when they intersected, they made four angles, angle 1, 2, 3, and 4. Okay, so how do you prove that angles 1 and 3 or angles 4 and 2 have the same measurement or are congruent? Okay, so we use a bit of deductive reasoning in order to do that. Okay, and we also use the linear pair postulate that we have previously discussed a while ago. Okay, so we previously discussed that postulate. Okay, so it says that any two angles that are that form a linear pair are supplementary angles, and also that they measure 180 degrees. Okay, so how do we do that? Okay, so the measurement, okay, so from the linear pair postulate, we can deduce that the measurement of angle 1 plus the measurement of angle 2, okay, measurement of angle 2 is equal to 180 degrees, okay, and the measurement of angle 2, okay, based on the figure, and the measurement of angle 3, okay, measurement of angle 2 plus the measurement of angle 3 is also 180 degrees. Okay, so we want to prove that the measurement of angle 1 and angle 3, okay, are congruent, okay, or are equal. Okay, so we want to know that, or we want to prove that angle 1 and angle 3 are congruent angles, since they are vertical angles. And let's state into the vertical angle theorem, or for theorem 1, if two angles are vertical, then they are congruent. Okay, so we want to prove that theorem. Okay, so how do we do that? Okay, so if you see here, we both have measurement of angle 2, okay, so we can equate the measurement of angle 2 as, okay, the measurement of angle 1 is equals to 180 degrees, okay, this is 180 degrees. Then we transfer the measurement of angle 2 to the other side. So from positive it becomes negative or minus angle 2. Okay, so that's the measurement of angle 1. Okay, so how about for the measurement of angle 3? Okay, so we have here a measurement of angle 3. Okay, and we also have an angle 2 here. Okay, so that's a 2. Okay, so the measurement of angle 2, when you transfer it to the other side, it's going to be the measurement of angle 3 is equal to 180 degrees minus, okay, 180 degrees. Okay, let's just write that neatly. 180 degrees minus measurement of angle 2. Okay, so we have here the measurement of angle 1 is equal to 180 degrees minus the measurement of angle 2, and the measure of angle 3 is also 180 degrees minus the measurement of angle 2. So that means, so it must prove that the measurement angle 1 is equal to the measurement of angle 3, even if we don't know their measurement. So we just prove that they are equal, and therefore angle 1, the vertical angles angle 1 and angle 3 are congruent. Okay, so therefore it must be that the measurement of angle 1 and angle 3 are congruent, and angle 1 are equal. Okay, and angle 1 and angles 1 and angle 3, angles 1 and 3 are congruent. So that's our A. Okay, so given with our knowledge about vertical angles, okay, so we know that if two angles are vertical, they are congruent. Okay, so given on the figure on the left, we want to find the measurements of angles 1, 2, and 3, and the value of x plus y. Okay, so we're going to take this problem step by step because it's a bit difficult, especially finding for the value of x plus y. But don't worry, the solution, we're going to make it easier for you guys, okay? So let's get to it. So the first step is we have to establish that angles 1 and 3 are congruent because they are vertical angles, okay? So since angles 1 and 3 are vertical angles, then they must be congruent. So we have here angles 1 and 3, okay? Or let's say the measurement of angle 1 and the measurement of angle 3 are equal, okay? So the measurement of angle 1 and angle 3 is equal. And also we have here the measurement of angle 2. Okay, so we can look at it this way. So we have here angle 2 and angle 3. So what if you look at it closely, they actually form a linear pair. Okay, so angles 2 and angle 3. Okay, angles 2 and angle 3 are linear pairs. Okay, so if they are linear pairs, okay, so angles 2 and angles 3 are linear pairs. Okay, so if they are linear pairs, then what's their measurement? Okay, so exactly, so they're supplementary angles, so that means that the measurement of angle 2 plus the measurement of angle 3 is equal to 180 degrees. Okay, that's good. Okay, so we have now this formula. Okay, so for the first one, well, angles 1 and 2 are also linear pairs, but we can't equate them because the angle 2 has an x and angle 1 has a y. Okay, so we won't be able to get anything out of that. But for here, for measures of angle 2 and angle 3, we both have x's here. 17 over 3x and then 7x minus 15. Okay, so when we add the measurement of angle 2, which is 17 over 3x. Okay, let's just write that quickly. 17 over 3x plus the measurement of angle 3. Okay, measurement of angle 2 is 17 over 3x, and then the measurement of angle 3 is 7x. Okay, 7x minus 15. Okay, so let's not forget to write the parentheses. So that must be equal to 180 degrees, and also we can equate these two algebraic expressions and find an answer because they only have one variable, which is x. Okay, so there we can solve this problem. So 17 over 3. Okay, 17 over 3x plus 7x. Okay, we just simply have to transfer the 15 there, the constant, to the other side. So it's going to be 180 plus 15, so that's going to be 195. Okay, and then you can simply just add 17 over 3 plus 7. Okay, so what's 17 over 3 plus 7? 17x plus 17 over 3x plus 7x, that's simply 38 over 3x. Okay, 38 over 3x. Okay, so that's 38 over 3x is equals to 195. Okay, and then we simply multiply this entire equation to the reciprocal of 38 over 3, so that's 3 over 38. Okay, so it cancels on the left side. Okay, so if you multiply this to the left side, it cancels. Okay, and what's 195 times 3 over 38? Okay, 195 times 3 over 38, the answer is 585 over 38. Okay, so that's the value of our x. We have 585 over 38. Okay, so we have solved the value for x. Okay, so now that we solve for the value of x, that's 585 over 38, we can substitute that for the value to get the value of angle 2. So what's the measurement of angle 2? That's simply 17 over 3x. Okay, so that's 17 over 3x. Okay, so what we do here is we simply substitute the value of x, which is 585 over 38. So that's the measurement of angle 2 is equal to 17 over 3 times the value of x, which is 585 over 38. Okay, so that's 38. Okay, 38. Okay, so let's write that one cleanly. 38. Okay, so if you use a calculator, okay, so that's 17 over 3 times, what was that? 585 over 38. Our answer is 3000. Okay, so the measure of angle 2 is actually 3,315. Okay, 3315 all over 38. Okay, so that's the measurement of angle 2. And since it's one of the angles that we are trying to find, okay, we have to write that into a decimal or transform it into a decimal. Okay, so if it's transformed into a decimal, we get 87.24. Okay, so the measurement of angle 2 is 87.24 degrees. Okay, but for for the exact measurement, you got 3,315 all over 38 degrees. So that's the exact measurement. Or if you want the approximate measurement using decimals, that's 87.24 degrees. Okay, now so we can get the measurement of angle 3. Okay, so we have the value of x, we can already get the measurement of angle 3. So that's just simply measurement of angle 3 is equals to 7x minus 15. Okay, so we have there 7x minus 15. Okay, so what's the value of x again? So that's 585 over 38. So we can substitute that value. Okay, 585 over 38. Okay, so when you use your calculator to solve that, okay, so that's going to be like 7 times 585 over 38. Okay, then minus 15. Okay, minus 15. Okay, so when we get that using our calculator, so that's going to be 7 times 585 over 38, so that's going to be 4,095 over 38, then minus 15. So the answer is 35.25. Okay, 35 25. So that's 3525 all over 38. So that's the measurement of angle 3. And since that's one also of the givens, one of the angles that we want to know the measurement, so we have to transform that into a decimal, or a whole number with a decimal. Okay, so that's going to be 92.76. Okay, so that's going to be 92.76 degrees. Okay, so that's the measurement of angle 3. And since the measurement of angle 3 is equal to the measurement of angle 1, okay, because they are vertical angles, angle 1 and angle 3 are vertical angles, then we can say that the measurement of angle 1 is also 92.76 degrees, or 3,525 over 38 degrees. Okay, so if you want the exact value. Okay, so when substituting, always remember that we have to substitute the exact value. Okay, so that's one for this one, 585 over 38. What we substituted here is the fraction, not the 87.24, so that we can get the exact values for the angle measurements. Okay, so we have the measurement of angle 1, 92.76 degrees, measurement of angle 2, 87.24 degrees, and measurement of angle 3, which is also 92.76 degrees. And we also have the value of x, which is 585 over 38. Now we only have to find the value of y. Okay, so moving forward, we have here the measurement of angle 1 is equal to 5y plus 16. We already solved the measurement for angle 1 and 3, that's equals to 92.76 degrees, okay, or 3,525 over 38 degrees. Okay, so we simply have to substitute this fraction, okay, to the value of the measurement of angle 1. Okay, since we've measured that our actual measurement is actually 92.76 degrees, or 3,525 over 38 degrees, we can put this value as the measurement of angle 1. So that's 3,525 all over 38 is equal to 5y plus 16. The reason we substituted that is because we already know the measurement from the previous computation that we had for solving the measurement of angle 1 and angle 3. And they are vertical angles, so that's why they have the same angle measurement. So we have here the value. So we have here 3,525 over 38. Okay, and then we have to since that's plus 16 there, we have to transfer it to the other side. It's going to be minus. Okay, so 3,525 over 38, okay, minus 16, okay, is equals to 5y. Okay, so what does 5y equal to? 5y is equal to, so if we subtract 3,000, okay, if we subtract 16 from 3,525 over 38, the answer is 2,917, 2917, okay, 2917 all over 38. Okay, so we're still not yet done. Okay, so we're still not done. Okay, so let's just write that cleanly. Okay, so what we have to do is we have to multiply this entire equation. 5y is equal to 2,917. Okay, so let's write that 2,917 to the reciprocal of 5. Okay, so that's 5y, so we have to cancel 5, and the reciprocal of 5 is simply 1/5. Okay, and if we multiply it there, it's going to be cancelled 5, and if we multiply 1/5, okay, 1/5 times 2,917 all over 38, your answer is going to be y is equal to 2,917 over 17. Okay, so no need to write that as a decimal because we're only looking for the value of y. Okay, it's not an angle measurement, so that's the value. Okay, again guys, so for solving for the value of y, we have 2917 over 38 times 1/5, so the answer is going to be 2917 over 190. Okay, so that's 2917 all over 190. Okay, so we have now the value of x, so the value of x is 585 over 38, and we also have now the value of y, 2917 over 190. So what we can do is we can equate the two values, x plus y. So that's going to be 585 over 38 plus 2917 all over 190, so that we can get the value of x plus y. So x plus y is simply so it's going to be 2921 all over 95. Okay, all over 95. And if you transform that into a decimal, well, this is the exact answer. X plus y is equal to 2921 over 25. Okay, but if you want to transform that into a decimal, so the answer is going to be 30.75. Okay, that's not the precise or the most accurate or the definite answer. Okay, but if you want an approximate, it's going to be 30.75. Okay, or the more appropriate answer, 2921 over 95. Okay, so we move forward to our new lesson. So we have introduction to parallel and perpendicular lines. Okay, so that's parallel and perpendicular lines. So we're not going to go in detail about these two big topics in geometry. So they're very big. There are a lot of theorems and postulates about them. So we're just going to give you an introduction about them, since we are going to discover or encounter them actually in some of our lessons in this first quarter during when measuring what they'll call this, the area of specific plane figures and the volume and surface area of specific solid figures. So we're going to encounter them, so that's why we need to discuss these topics. So the first one, of course, are parallel lines. So we're very common, it's very familiar to us. So parallel lines are coplanar lines that are parallel, of course, and do not intersect. So the meaning of parallel is that these lines never intersect on a plane. And we also have skew lines. Skew lines are lines that are not parallel and do not intersect. Okay, so on the figure given here on the top, so we have here a cube, and there's a parallel line. Okay, there are two parallel lines, a pair of parallel lines. So we have line BT and line EA. Okay, so those lines never intersect, they will never intersect on this plane figure. And we also have a skew line. Okay, a pair of skew lines, so are lines that are not parallel and do not intersect. So we have here line BT and line RI. So these two lines will never intersect. And also with line EA and also line RI. So those two lines will never intersect. Okay, so we have those two lines, so parallel lines and skew lines. So moving forward, we have the perpendicular lines. Okay, perpendicular lines are any two lines if and only if they form a right angle. Okay, so when you hear the word perpendicular, it always has to be like those two lines have to create a right angle or some right angles. Okay, so we can see here on theorem 2, if two lines are perpendicular, then the pairs of adjacent angles that they form are congruent. Okay, so it just says that, let's say for example, you have there line U and line V. So when they intersect, the pairs of adjacent angles that they form are congruent. Okay, so to prove that, as you can see, if line U and line V intersect, okay, so if those two lines intersect, they will form a right angle. Okay, so the first right angle is called angle 1. So the measurement of a straight angle, that's 180 degrees, right? So if the measurement of angle 1 is 90 degrees, so the measurement of angle 2, since angle 1 and angle 2 are on a straight line, okay, so that's 180 degrees. So 180 minus 90, so the measurement of angle 2 is also 90 degrees, and therefore the measurement of angle 1 and the measurement of angle 2 are the same, so they are 90 degrees. Okay, so it follows that if two lines are perpendicular, then the four angles that they form are congruent. So that's corollary number 1. Okay, so if two lines are perpendicular, as we can see, that's line U and line V, they are perpendicular, then the four angles that they form, angles 1, 2, 3, and 4, are congruent. And also for corollary number 2, if two lines are perpendicular, then all four angles that they form are right angles. Okay, so that's angle 1, 2, 3, and 4. They all measure 90 degrees. Okay, so now that we formed, or we have already proven theorem number 2, which simply states that if two lines meet and they form a right angle, then the pair of adjacent angles are congruent. We now move to theorem number 3. This is still introduction to parallel and perpendicular lines, so with a more focus on perpendicular lines. So theorem number 3, if there is any given point on a line in a plane, then there is exactly one line in that plane perpendicular to the given line at the given point. So we have here an illustration shown on the left. Okay, so to prove theorem number 3, we need to introduce the concepts of existence and uniqueness. Okay, so we have here two lines, line FR and line EA, or segment FR or segment EA. Then we have point I, okay, at the middle, and then it lies in plane C. So the existence concept states that there exists line FR in plane C, such that line FR contains point I and line FR is perpendicular to line EA. Okay, so that proves theorem number 3. And we also have uniqueness. Only one line FR in plane C is perpendicular to line EA at point I. So that means only line FR is the only line there that is perpendicular to point I in plane C. Okay, so it's perpendicular to line EA. Okay, so there's only one unique line. Okay, and there exists for existence there exists line FR in plane C that contains point I, and that is perpendicular to the line EA. Okay, so there. So we have there the concepts of existence and uniqueness to prove theorem number 3. Okay. And then we have the perpendicular bisector, the concept of a perpendicular bisector. A perpendicular bisector is any segment, or is it okay? So a perpendicular bisector of a segment is a line, a segment, a ray, or a plane that is perpendicular to the segment at its midpoint, and thereby bisecting the segment into two congruent segments. Okay, so this perpendicular bisector only works on segments, okay, because they have two endpoints and there's a midpoint there. Okay, so let's for example, there's a given if point I is the midpoint of segment EA, so that means I is the midpoint, and segment FR intersects with segment EA at point I only, then segment FR is the perpendicular bisector of segment EA. So what does that mean? So that means the segment FR divides the segment EA into two equal parts. So that's segment EI and segment IA. Okay, and it was also stated in the given that point I is the midpoint of segment EA. And therefore, it follows a corollary from theorem number 3. The corollary of theorem number 3 is that if there is given any segment in a plane, okay, then in that plane there is exactly one line that is a perpendicular bisector of the segment. Okay, so why only one line? Why not 2 lines, 3 lines? Because there is only one midpoint on segment EA. Okay, so and in all lines there's only in all segments there's only one midpoint. Okay, so that follows that only one line is the perpendicular bisector of a given segment. Okay, so that concludes our lesson on relation among lines and angles. So again, I am Mr. John Manuel B. Padre, teacher for plane geometry for additional mathematics for grade 8 students in Makati Science High School, and have a great day.